Hello. Yes, my name is CA Yogesh, and we are doing statistics standard 12 part 2 chapter number 1, that is probability. Yes, we have started the chapter probability, and we have completed almost 3 lectures till now. In last lecture we have started the type of events. I told you what is event. Okay, if sample space is a cake, then event is a pastry. Sample space is whole of the units as whole, and events are a part of the sample space. Yes. And what are the type of events? It is union of events, intersection of events. So union of events is, I told you that if A is 1, 2, 3, 4, B is 3, 4, 5, 6, then A union B is 1, 2, 3, 4, and 5, 6. This event A or event B occurs, at least one event occurs. I'll be explaining in the later part of the chapter. Then intersection of events. What is intersection of event? Now is if A is 1, 2, 3, 4, B is 3, 4, 5, 6. Then if you combine both this 3 and 4, uh, it's A intersection B. It's not a combination, but it's a common element between A and B. So what is common in A and what is common in B? The elements which are in A also and in B also. It is known as an intersection of events. So let us proceed further. Let us start the third event. We will name this third event as complementary. Now, what is complementary event? Let me take an example. If sample spaces, if sample space is 1, 2, 3, 4, 5, 6, and 7. If sample space is 3, 4, 5, 6, and 7. Let event A be 1, 2, 3, 4. Let event A be 1, 2, 3, 4. Now, what is complementary event? What is complementary event? You can say the element present. You can say that element present in sample space. What? Element present in sample space other than event A. What I'm trying to say? I'm trying to say, for example, in sample space, this 1, 2, 3, 4. These 4 digits are present in A. Now, the digits other than this 1, 2, 3, 4. What are the digits other than 1, 2, 3, 4? 5, 6, 7. So, these 5, 6, 7 are known as complementary, and this 5, 6, 7 is denoted as A dash. Okay, this is A dash means A complement. Okay, this is A dash, that is A complement. Okay, so A complement is 5, 6, and 7. A is 1, 2, 3, 4. A dash is 5, 6, and 7. So if I write in simple terms, then event, or you can say element, present in sample space other than elements of event A are called as complementary events. Elements present in sample space other than elements of event A are called complementary events. So sample space is 1, 2, 3, 4, 5, 6, 7. A is 1, 2, 3, 4, and A dash, as I told you, that is 5, 6, 7. Now I'll be teaching you a bit difficult and bit important event. Difference event. What is this difference event now? This difference event you need to understand. There are two type of difference event, I can say. It's A minus B, and it's B minus A. It's A minus B and B minus A. Now, sir, what is A minus B and B minus A? Let's illustrate it. That means let's take an example. A is 1, 2, 3, 4, and 5. Okay. Then B is 4, 5, 6, 7. A is 1, 2, 3, 4, 5, and B is 4, 5, 6, 7. Now, what is A minus B? See, what you need to do. If I explain you in the language term, what is A minus B? A minus B means if you have to subtract the elements of B from A. A minus B, that means A minus B. So what we will do, we will be subtracting the elements of B from A. So what are you telling, we don't understand it. I'll be explaining in very lucid terms. See, A is 1, 2, 3, 4, 5. In this 1, 2, 3, 4, 5, these two elements are present in B also. So I can say these two elements are of B. Okay. So what we'll do, we'll subtract those units, or we'll subtract those elements which are present in B. Okay, so A minus B will be what? A minus B will be 1, 2, and 3. What's my point? What we have done? We have just subtracted the elements of B from A. It is A minus B. The same way you can do B minus A. The same way you can do B minus A. What will you do? You will subtract, you will be subtracting A from B. So in B, these two particular digits are in A. Which digits? 4 and 5. So I'll be subtracting 4 and 5 and will be putting 6, comma 7. Okay. So this 6 and 7 is what? This is B minus A. Okay, I have subtracted A from B. Now what exactly you have done? If we'll be writing with the formula, then A minus B is equal to A minus A intersection B. It is A minus A intersection B. See, you can see here that in particular the sum given, what is A intersection B? A intersection B, that means common. So 4 and 5 is common. Okay, in A intersection B, 4 and 5 is common. So from A you have subtracted 4 and 5. This 4 and 5 is intersection. So if you subtract A intersection B from A, you will be getting A minus B. In the same way, the formula for B is B minus. So steps are same. Here it is B minus A intersection B. So steps are same. It is B minus A intersection B. What is this, sir? This is B minus A's formula. This is B minus A's. Okay, so B minus A is B minus A intersection. So what actually the A minus B is? A minus B, that means only event A occurs. And here I will be writing only event B occurs. Okay. Now this thing, as I told you, I'll be explaining you the later part of the chapter. So we have done 4 events. Let us start with the fifth. So now fifth is mutually exclusive event. What is mutually exclusive event? Oh, mutually exclusive event is what? Say for example, okay, let us write first. If there is no intersection between event A and event B, if there is no intersection between event A and event B, then event A and event B are known as. If there is no intersection between event A and event B, then event A and B are known as mutually exclusive events. So still we have some doubt. Then let's take an example. Say for example, event A is 1, 2, 3, and event B is 4, 5, 6. Now here, can you see any intersection? Can you see any intersection here? Yes or no? No. Intersection is null set. Now if intersection is null set, here A and B are mutually exclusive. event. Okay, so A intersection B is nothing. So here you can say event A and event B are mutually exclusive events. Let us start the sixth one. So you got my point now here in mutually exclusive. See, if there is no intersection, then they are mutually exclusive. Okay. If you don't get it clear, then let me take opposite example. Now, what is opposite example? Here, let me take A as 1, 2, 3, and B as 3, 4, 5. So here, A intersection B will be 3. As you can see, that there is intersection between A and B. Now here, A and B are not mutually exclusive. Okay, so now I am clear. If there is an intersection, it is not mutually exclusive. Is if there is intersection, it is not mutually exclusive. If there is no intersection, then it is mutually exclusive. So you have to learn by heart. Then coming up to exhaustive events. Now, what are the exhaustive events? Let's take an example. U is 1, 2, A is 1, 2, and B is 3, 4, 5. Now, if you make the union, that is A union B. What is A union B? It's 1, 2, 3, 4, 5. If A union B matches with U, if A union B matches with U, then A and B are known as exhaustive event. So you can write like this. If A union B is equal to U, if A union B is equal to U, then event A and event B are known as exhaustive events. Okay, if A union B is equal to U, then event A and event B are known as exhaustive event. For example, U is 1, 2, 3, 4, 5, 6, 7. A is 1, 2, 3, 4, B is 3, 4, 5. Then union will be 1, 2, 3, 4, 5. Then this both will not be exhaustive event. So that was the opposite example. Okay. Now let us combine these. Mutually exclusive and exhaustive events. Now, if if both the thing sets, which both things are, say for example, U is 1, 2, 3, 4, 5. E is 1, 2, 3, and B is 4 and 5. See now, if in any sum the two conditions of your is of your mutual exclusive and one is of your exhaustive. If both the condition matches, which were these two conditions? See, A intersection B is null set. and another A union B is equal to, you can see here A and B. If you do the union of A and B is 1, 2, 3, 4, 5, so it is matches with you. If both the conditions satisfies, okay, then here A and B are known as mutually exclusive event and exhaustive event. Okay, so here A and B are known as mutually exclusive and exhaustive event. You can see both the conditions satisfied. Now the seventh event is the combination of fifth and sixth event. Okay. You can see in the above example in exhaustive there is an intersection. 3 is the intersection. So here A and B is exhaustive. Yes, I agree. But they are not mutually exclusive as there is intersection. Here in example there is no intersection. So it is mutually exclusive and A union B matches with U. So it is exhaustive also. So in the same sum both the quality matches. So it is mutually exclusive also and it is exhaustive event also. So here event A and B are known as mutually exclusive and exhaustive events. So we have completed almost all the major events. Few more events are with us. Let us complete all the events today. Now this is elementary events. What is elementary events, sir? Event consisting of one element. Event consisting of one element are known as elementary events. Event consisting of one element are known as elementary events. How, sir? Say for example in A there is a digit 5. Now there is only one element, so this is known as elementary. Okay, it is as simple as that. Now ninth event is impossible event. Impossible event means event which is not possible. Event which is not possible. You know, sun rises in east. If you say it rises in west, not possible. Okay, there are many examples which are not possible. Okay, if you throw a dice, you cannot get number 8 because there is no number 8 in dice. It is not possible. Event which is not possible is known as impossible event. And impossible event that means null set. Okay. Then 10th one is certain event. You can say event which is always possible, or you can say event which always occurs. This is 110% sure. This is actually the simple case event which always occurs. Okay, there is Monday after Sunday every time. Did you notice the Tuesday after Sunday? No, there is always Monday after Sunday. So event which always occurs, certain event, sure 100% event. This is the simple case. It always occurs. So we have completed the type of events. Let us go through once again in all the events. Now these events are very important, as I told you in starting also. You should know what events are there, and you should learn with the names. If I say you A and B are mutually exclusive, then you should be having in mind what is mutually exclusive and what exactly I am telling about the event A and B. Okay. In questions, it will be only written A and B are mutually exclusive. You have to conclude that what is the mutually exclusive, and you have to solve the sum by that meaning. Okay. So we have done almost 10 events. Number one was union of events. What is union of events? You have to combine the event A and event B. If any element is repeating, then you have to write it only once. So combination of event A and event B are known as union of events. Then intersection of events. What is intersection of events? The common element. The common element in event A and event B are known as intersection of events. The common elements between event A and event B are known as intersection of events. Then complementary event. I told you that in sample space, if U is 1, 2, 3, 4, 5, 6, 7, if A is 1, 2, 3, 4, then 5, 6, 7 will be a complement. Okay, if A is 1, 2, 3, 4, then 5, 6, 7 is a complement. Then difference event. What is difference event? I told you that there are two type of difference event, A minus B and B minus A. What is A minus B? You have to subtract intersection from A. Okay, so if A is 1, 2, 3, 4, 5, what is the intersection? 4, 5. Just remove that 4, 5. So A minus B is 1, 2, 3. Exactly the same way we'll be doing in B minus A. We'll be subtracting intersection from B. So if B is 4, 5, 6, and what is the intersection? 4, 5. We'll be subtracting that 4, 5. And mutually exclusive event. Now what is mutually exclusive event? I told you that if there is no intersection between A and B, A and A intersection B is null set, then A and B are known as mutually exclusive event. If there is intersection, they are no mutual. Exhaustive. What is exhaustive? If you combine both A and B, that is union, and your union matches with simple space, then A and B are known as exhaustive events. If your union doesn't match with the simple space, they are not exhaustive. It is as simple as that. And 7 month mutually exclusive and exhaustive. What is mutually exclusive and exhaustive? If in example both the conditions satisfies, that is A intersection B is null set and A union B is U, then they are known as mutually exclusive and exhaustive events. What is elementary event? Elementary event means event consisting of only one element. Okay. So if say for example in event A there is only one element 5, then it is known as elementary. Then last two, impossible and certain. Impossible, that is not possible, and certain, which is always possible. So we have done type of events, and we'll be continuing further in the next lecture. Thank you.